finally, last example for lesson 6.4. Here we're going to be doing work. Do work, son. I know this will be new for some of you guys, but we're still going to try to do some work. So there's a couple different formulas you could use. The work, W, is done by a constant force F as its point of application moves along the vector PQ is given by either form. So you can have projection form or the dot product form. So you have your work is equal to the projection of F, or P on a Q on F, times the magnitude of PQ, or you may have to use W is equal to the dot product of your force times your PQ vector. So what we have here is we need an object that's sliding across the floor. The person is pulling a rope with a constant force of 25 pounds at a constant angle of 30 degrees above the horizontal. Find the work done if the object is dragged 40 feet. So it'd probably help if we drew a little picture here. So we're going to have this person that's going to be dragging this at 30 degrees. They're going to be around the edge. And they're pulling this rope, they're pulling some box across the floor here, sliding across, and they have the rope in both their hands. And you have 30 degrees down here on the bottom. And we have to figure out if we have a force of 25 pounds, then that would be on here as the force. Then we need to figure out what our work is done if the object is dragged 40 feet. So let's look at finding our work done if we have the projection. Let's use this one up here. We're going to find the projection of PQ onto F multiplied by the magnitude of PQ. Now, the reason we're multiplying by the magnitude of PQ is because we are actually given the magnitude of PQ, which is 40 feet. So this is our vector PQ. The magnitude of PQ is a length or a distance, and that is 40 feet. So that's why we want to use option number 1 up here and not option number 2. We don't have any vector forms for PQ yet anyway. So if we want to find the projection of PQ onto F, the way we do this is we're going to take the cosine of 30. That's nice handwriting. The cosine of 130. Now, why do we use the cosine? Well, your cosine is your horizontal distance. So we're going to take the cosine. So since we are moving it horizontally, then that means we have to do the horizontal component, which is cosine, not sine. The cosine of 30 degrees times your magnitude of F. So the magnitude of F is 25. Oh man, my pen is really messed up. 25, looks like it has beards all over it. Times your magnitude of PQ, which is 40. So basically, it would look a little bit better if maybe we wrote it as 25 cosine of 30 degrees times your magnitude of your F, or your force, which is 40. So when we type these in, plug them into your calculator, the work done ends up being 866 foot-pounds, which means that is how you measure work being done. So there you go. I hope you enjoyed lesson 6.4. Before we get to the word problems, it's a little bit easier, but keep in mind, try to draw a picture, and then try to figure out what vector you are trying to find.